Hello, hello! Here is the video going over the Unit 3A test review on linear functions. The test review goes over finding slope, graphing lines, writing equations for lines, as well as working through some applications. So first and foremost, let's start by writing down what the equations are for all of the different forms of linear functions, as well as the formula for slope. So the formula for slope is when you're trying to find the slope between 2 points. So I have m equals y2 minus y1 over x2 minus x1. Slope-intercept form is y equals mx plus b, where m is your slope and the point 0b is your y-intercept. Point slope form is another way to write linear equations. So I have y minus y1 equals m times x minus x1, where once again m is your slope and the point x1, y1 is any point that is on the line. And standard form is ax plus by equals c, and we usually use standard form when we're graphing with intercepts as well as when we're working through some of the applications. Okay, so number 1 says to label each equation to identify if the slope is positive, negative, 0, or undefined. If I look at letter A is in slope-intercept form, which means the number in front of my x represents my slope. Well, is 1/2 positive or negative? I can clearly see that that 1/2 is positive, so that means my slope for this one is going to be positive. Letter B. So letter B, I just have x equals -9. So when I have x equals a number, what that's going to do is that is going to create a vertical line. And vertical lines are so steep that the steepness is undefined. For letter C, y equals -2x. This one, once again, is in slope-intercept form. So the number in front of my x represents my slope. So in that case, it is negative. Y equals 4. So y equals 4, you can think of it one of two ways. It is actually in slope-intercept form. I could write it as y equals 0x plus 4. And I can see my slope in this form is 0. Or, since my slope for x equals a number is undefined, because it's a vertical line, y equals a number is going to be a horizontal line. And slope always represents steepness, and if I think of a horizontal line has no steepness whatsoever. So my slope for that is also 0. For letter E, once again, slope-intercept form, and I can see that my slope number in front of x is negative. And letter F, also in slope-intercept form, and if there is no number in front of x, the number that is there is a 1, which I can see is positive. All right, find the slope of each line. So in order to find the slope of a graph, what I'm going to do is I'm going to look at rise over run. So I'm going to travel from one point to the next. So from here, I need to go up 2 and to the right 1. So that means my slope is going to be 2 over 1, which is also just 2. For letter B, I'm going to do the same thing. Starting at that point, I need to go down 6 and to the right 4. So down 6 to the right 4. So I have -6/4, which I always want you to reduce if you can, and that becomes -3/2. And if I look at my line for letter C, it is a vertical line, and vertical lines have an undefined slope. All right, next up. Oh, we're still finding slope. I thought we were switching gears to writing equations, getting a little ahead of myself. So finding the slope between 2 points. So in order to find the slope between 2 points, I'm using my slope formula, which if I go back to the first page, is this point or this formula right here. I'm just going to rewrite it on this slide so you can see it as I go. So m equals y2 minus y1 over x2 minus x1. I'm going to go ahead and label my points x1, y1, x2, y2. And I'm just going to plug in those numbers in their respective spots. So I have y2 minus y1 over x2 minus x1. So 3 minus 2 is 1, 11 minus 8 is 3. So my slope for this is going to be 1/3. For letter B, again, x1, y1, x2, y2. I have y2 minus y1 over x2 minus x1. That gives me 0 over 6, and 0 divided by 6 is 0. x1, y1, x2, y2. So I have y2 minus y1 over x2 minus x1. Now, if you'll notice, I am subtracting negatives. So when I do subtract a negative, that changes to addition. So what I'm really looking at is 3 plus 4 over negative 2 plus 2. That gives me 7 over 0. Now, you can never divide by 0, and my 0 is underneath, which means my slope for that is undefined. All right, another one. x1, y1, x2, y2. So I have y2 minus y1 over x2 minus x1. Subtracting a negative once again. So I'm going to rewrite it. I have negative 3 minus 7 gives me negative 10 over negative 5 plus 1. That gives me negative 10 over negative 4. Both of those numbers can be divisible by 2. I'm also dividing a negative by a negative, which gives me a positive 5/2. So my slope for letter D is 5 over 2. Now we're going to equations. Okay, so it says write the equation of the line given the following information in any form. So any form means I could use slope-intercept, which is y equals mx plus b, or I could use point slope, which is y minus y1 equals m times x minus x1. Now, a couple of things. In order to use slope-intercept, I absolutely need to have my y-intercept. Point-slope form, on the other hand, can be used with any point, either the y-intercept or any point that is on the line. So if I look at letter A, I have my slope, my m is 2, and my y-intercept is 0, negative 7. That means that negative 7 is the b. So I can go ahead and write this one in slope-intercept form. I'm going to replace my m with 2 and my b with negative 7. For letter B, I have a line that passes through 2 points. So for this one, I wasn't actually given my slope. I have 2 points, but I can find my slope just like the other problems we just did. So I have x1, y1, x2, y2. So I have y2 minus y1 over x2 minus x1. That gives me 11 minus 8, which is 3 over negative 4. Now, if I look at my points, I actually do have the y-intercept. I can tell that that point is the y-intercept because my x-coordinate is 0. So really, this 8 right here represents your b. So I can write this equation in slope-intercept form. I have y equals negative 3/4 x plus 8. Or, if you really want to, you can write it in point-slope form as well. So if I wanted to do point-slope form, I'm actually going to use the other point for point-slope form so you can see a little bit of a variation. So I have y minus my y-coordinates equals m times x minus my x coordinate. But if you'll notice, I'm subtracting a negative 4, so that will become x plus 4, since you're subtracting a negative. And you could use point-slope form with the y-intercept as well, but I'm not going to write that one down. Okay, letter C. If I look at my graph, I need to start by identifying my slope. So once again, rise over run. So going from one point to the next, I am going down to, uh-oh, something just happened. Okay, sorry, my iPad was freaking out at me for a second. Okay, so I'm going down 2 and to the right 3. So my slope for this one, I'm going to write it on the side, m equals negative 2/3. Now if I look at my graph, I can see that it crosses my y-axis at 0, 3. So I can go ahead and use slope-intercept since I do have my y-intercept, and that 3 represents the b. So I have y equals m, which is negative 2/3, x plus b. Now let's say I wanted to use point-slope form. So if I wanted to use point-slope form, say with this point over here, the coordinates of that point are negative 3 and positive 5. So I'm using the same slope. So if I wanted to do point-slope form, I would do y minus my y equals m, still negative 2/3 because we're on the same line, and x minus negative 3 becomes x plus 3. You could also use this point over here if you wanted to, but again, I'm not going to show you every single answer that goes with these problems. Okay, a table. So when I have a table, I still need to find my slope. That's going to be change in y over change in x. So if I look at my y's, let's see how these are changing. I'm going from negative 3 to 1 to 5 to 9. So each time I am adding 4. And if I look at my x's, each time I am adding 1. So my slope is my change in y over my change in x. So 4 over 1, which of course is just 4. Now if I look at my table, I do not have any coordinates where my x value is 0. So I don't actually know my y-intercept. I could find it out if I really wanted to. I could continue the patterns for my x's and y's going in the opposite direction until I get to 0. But since I don't have to do slope-intercept form, I'm just going to pick any point and use it for point-slope form. So I have y minus the y equals m, x minus the x. And of course you could pick the other 3 points as well, and you could have 3 other equations for letter D. Okay, steepness. So given the line y equals negative 2x plus 7, write an example of a line that would be less steep than this line or more steep than this line. So when we're talking about steepness, what we're doing is we are looking at the slope. So I'm going to write m equals negative 2 on the side. Now the negative just tells us the direction our line is moving in. So I'm going to go off on a little bit of a tangent. When I have a positive m, my slope goes in this direction, or my line goes in that direction. When I have a negative n, my line is going to go in that direction, going down as we move to the right. So the negative really just tells us the direction our line is moving. It does not describe the steepness. What does describe the steepness is this number right here, the 2. So if I want a line that is steeper than this particular line, that means my number has to be bigger than 2. So for example, say 3. So I could write y equals negative 3x plus 7. You don't even have to make it negative. It could just be a positive 3x plus 7. It's still going to be steeper than the original line. In order to find a line that is less steep, I want a number that is smaller than that 2, preferably between 0 and 2, because once again, we're just looking at the positive values. We don't want to go negative, because you could end up going more steep, going off on a tangent. Sorry. So I want a number that is smaller than 2, but bigger than 0. So I'm going to go with, we'll keep it simple, y equals negative 1x plus 7. If you want to get fancy, we could make it a fraction. So y equals negative 1/3 x plus 7. You just need some number that's smaller than 2. All right, and I kept my y-intercepts the same just because I wanted to, but since you're just talking about steepness, it really doesn't matter if you have that 7 there or not. Okay, determine if the table, the equation, or the description match the graph. Right, yes or no for each. So letter A is looking at these points. So 1, 4. I'm actually going to plot these points to see if they're on the line. So 1, 4. Well, that one's on the line, so far so good. 2, 7. Oh, there's another one. And 3, 10. All right, that was on the line, so this is a big fat yes. The equation y equals 3x plus 4. So if I look at this equation, that means my slope is 3, and my y-intercept is 0, 4. So let's see if that matches what I have. I'm going to erase the points that I plotted so I can plot new points. So I'm going to begin at my B. I am beginning at my y-intercept, which right when I plot that, I can already see it is not on the graph. So this one is a big fat no. Okay. And let's read the description. As the y value increases by 3, the x value increases by 1. So let's start with the point on the graph. I'm going to increase my y value by 3, and I want to see if my x value increases by 1. Oh, it certainly does. So that is going to be a yes. So what letter C is describing, it's actually describing the rise over the run. So the y value is your rise. The x value increasing is your run. So the slope is 3 over 1, which does indeed match the graph. Okay, x and y intercepts. So when I'm trying to find the intercepts, what I want to do is I want to plug in 0 for the other variable. So when I'm trying to find my x-intercept, I am going to plug in 0 for y. What that does is the y portion of my equation is going to cancel itself out because that's just going to equal 0. So I have 3x equals 15, so x equals 5. Now anytime you're writing an intercept, you should always write it as an ordered pair. So my x-coordinate is 5 and my y-coordinate is 0. Now for my y-intercept, I'm going to plug in 0 for x. And of course, when I do plug in 0 for x, that portion of my equation is going to disappear, right? Because 3 times 0 is just 0. So really what I can do is I can just write out the equation 5y, negative 5y, don't forget your negative, equals 15. Divide both sides by negative 5, and you get y equals negative 3. For my y-intercept, x is 0, y-coordinate is negative 3. All right, moving on to graphing. So letter A is doing the x and y intercepts, which we just did. So I'm going to go ahead and set up my two equations. I'm going to do 2x equals 6 for my x-intercept, because again, my y portion is going to disappear since I'm plugging in 0. So I get x equals 3. So my x-intercept as a point is 3, 0. For my y-intercept, I'm going to plug in 0 for x, and that leaves me with 3y equals 6. So I get y equals 2. And of course, I'm going to write that as an ordered pair. My x is 0, y is 2. Now in order to graph that, I am going to plot both of those points. 3, 0, my x-intercept is always on my x-axis, and my y-intercept is always on my y-axis. And I can go ahead and connect those two to draw my line. I think it's pretty straight. Yeah, I think it looks good. Okay, letter B. So if my slope, this one is in slope-intercept form, so my slope is the number in front of x, which is 4, and my y-intercept is 0b, or in this case, 0, 2. So I'm going to begin at my B. I'm going to begin at 0, 2, and my slope is 4. So what that means is I'm going to move up 4, 1, 2, 3, 4, and over 1. Because I can write 4 as a fraction as 4 over 1, and that'll show you that rise over run. I'm going to go up 4, 1, 2, 3, 4, over 1. And I might as well go in the opposite direction as well. So I can fill in the graph, which is going to make my line, when I do draw it, be even more accurate. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so now I can connect those dots. Oops. Go in that direction and in that direction. Oh, I should also draw little arrows at the ends of my lines, because these lines will go on forever and ever. All right, letter C. So letter C is in point-slope form. So for point-slope form, my m is the number that's in front of my parentheses. So my slope for this is 3. And for my point, I'm going to take my x-coordinate from the parentheses with the x, but as I pull it out, I am going to take the opposite. So that becomes -1, and my y-coordinate is going to come from the y. So my starting point is going to be at -1, 2. My slope is 3, which once again is the same thing as 3 over 1. So I can go up 3 over 1. Up 3, 1, 2, 3, over 1. Going to go in the opposite direction as well, just for the sake of accuracy. There we go. And I can draw my line in both directions, and my arrows, since these lines are going to go on forever and ever. Okay, letter D is in slope-intercept form, so my number in front of x is my slope, which is -3 over 2, and my y-intercept is 0, -4. So I'm going to begin at my B, and I'm going to use my m to move. So my slope is -3 over 2, so from this point I'm going down 3 over 2, down 3 over 2. Going to go in the opposite direction as well, up 3 to the left 2, since I'm going in the opposite direction. I'm going to fill my graph, and then I am going to draw my line. There's one portion. Whoa! Well, that's just really crooked. Let me try that again. Let's try that again. Take 2. There we go. That's better. Draw my arrows, because these lines go on forever. Got these 2 random blue dots here that I'm going to erase. Okay. All right. X equals 4. So what I'm going to do, since I have x equals 4, I'm going to go to my x-axis, and I'm going to plot a point at 4. Now, what I also need to do is I need to find another point where my x-coordinate is 4. So another point where my x-coordinate is 4 is either above or below, right? Because every single point on this vertical line is going to have an x-coordinate of 4. So I can go ahead and draw my vertical line, and every single point on that line is going to have an x-coordinate of 4. Now, a couple of things to remember. Anytime you have x equals a number, that sucker is going to be a vertical line, which means it has an undefined slope. Okay, so y equals -5 is going to be a horizontal line with a slope of 0. So let's see how that works. I'm going to go to -5 on my y-axis. I need to find other points where my y value is -5, and that can be any point to the right or to the left, because any of these points on this horizontal line will have a y value of -5. So again, going to make a little note. When I have y and a number, y equals a number, that is going to be a horizontal line, horizontal, with a 0 slope. Now, anytime you have an equation with both an x and a y, that is going to be a diagonal line, which is what we have been graphing for the past 2 slides. So x and a number is going to be vertical, y and a number is going to be horizontal. All right, word problems. So ticket sales at the MVHS volleyball game are $5 for students and $7 for non-students. The ticket sales for the game totaled $386. Let x represent the number of student tickets and y represent the number of non-student tickets sold. Write an equation for the scenario in standard form, ax plus by equals c. So I have x represents the student tickets, and y represents the number of non-student tickets. So student tickets are $5 for students, so I have 5x. Non-student tickets are $7, and they made a grand total of $386. So there's my equation in standard form. In order to graph these, you always need to find the x and y intercepts. So I'm going to go ahead and plug in 0 for x for my y-intercept, and plug in 0 for y for my x-intercept. And that's going to leave you with these 2 equations. So 5x equals 386, and 7y equals 386. Divide both sides by 5. I'm going to plug that into my calculator. So 386 divided by 5 is 77.2. So my x-intercept is 77.2, 0. For my y-intercept, I'm going to take 386 and divide it by 7. I'm going to go ahead and round to 1 decimal place. So y equals 55.1. Okay. So once you find your x and y intercepts, it'll help you scale the x and y axes of your graph. So part C, we haven't even done the graph yet. Well, I'm just going to go ahead and graph it anyway. Graphing is letter D, but I'm just going to go for it. So make sure you label your axes. So my x-axis, well, x represented the number of student tickets, so I'm going to label this as number of student tickets. And my y-axis was the number of non-student tickets. Okay, now for my tick marks, I'm going to go ahead and do them by tens. I'm actually not going to label every single one just because the numbers are going to get quite crowded. So I'm going to do this one as 20, 40, 60, 80, 100. I'm going to do the same thing on my y-axis. So 20, 40, 60, 80, 100. And my x-intercept was at 77.2. So this tick mark is 70, and we want 77.2 approximately. So that is going to be in between this tick mark and the 80, but closer to the 80, so I'm going to put it right here. And my y-intercept is at 55.1, so here is 50. So we want 55, so I'm going to put that right in the middle. And I can go ahead and connect these 2 points, and that gives you your lovely graph. Okay, so we did letter D before we did letter C. That's okay. So explain the meaning of the x-intercept in the context of the problem. So the x-intercept is where it crosses the x-axis. And if I look at my point for the x-intercept, that is when y equals 0. So that means that there were no non-student tickets sold for the x-intercept. So I'm going to write down, explain the meaning of the x-intercept in the context of the problem. The x-intercept shows how many non-student tickets there would be if no student tickets were sold. And similarly, my y-intercept, which it doesn't ask for, but if you were asked about the y-intercept, your y-intercept for this scenario would be would show you how many, did I write that down wrong? The x-intercept shows how many, oh, I wrote down, shoot, that was wrong. What I was writing down was the interpretation of the y-intercept. Oh boy. Okay, let me do some erasing. The x-intercept shows how many student tickets there would be if no non-student tickets were sold. Sorry about that. There we go. Okay. So what I originally wrote down was the interpretation of the y-intercept. X-intercept tells us the number of student tickets that would have to be sold if there were no non-student tickets. And I just realized that I spelled tickets wrong. Oh my god. Tickets. There we go. Okay. If 24 student tickets were sold, how many non-student tickets were sold at the game? So I have 24 student tickets, so I'm going to go ahead and plug in 24 for x, since x represents the number of student tickets. So I have 5 times 24 plus 7y equals 386. Well, 5 times 24 is 120. Plus 7y equals 386. Going to subtract 120 from both sides, run out of space, so I'm going to shimmy over. So 386 minus 120 is 266. And divide by 7, which gives me 38. So this would be 38 non-student tickets. Don't forget to label. Put units on your answers, because that's always important, especially when we're talking about word problems. Okay, one more question. So use the graph to answer the following. What is the slope of the graph? So in order to find the slope, I'm actually going to label some of my points. So this point right here is 0, 800. And this point right here is 4, 600. And I'm going to go ahead and find my slope using my slope formula. So I have m equals y2. So I'm going to go ahead and label my points. x1, y1, x2, y2. So y2 minus y1 over x2 minus x1. That gives me 200, negative 200, over 4, which is negative 50. Okay, now if I look at my units on my x and y axis, my x-axis represents months and my y-axis represents the bank balance. So that's going to help us interpret what the slope means for this given situation. So what that means is that every month your balance is going down $50. So I'm going to go ahead and write down the balance. Can't spell. The balance decreases by $50 each month. Okay, y-intercept is where it crosses the y-axis, and the y-intercept is at 0, 800. You should always write it as a point, so 0, 800. What does the y-intercept mean for the given situation? So if I look at my y-axis, once again, it's talking about the bank balance. So the y-intercept is the initial balance in the bank account. So the initial balance, oh man, my Apple Pencil's not cooperating. The initial balance in the account is $800. All right, so that concludes the video going over this test review. Good luck on your test.